Alright, so for the screencast this week, I got a script off of the website for the Celestia scripts. This one is called A Tour of Venus, and currently right now, they're zooming in on the Earth, and I believe they're going to be pointing over to Russia, and that is where a spacecraft was sent from, or a probe was sent from Russia to Venus, where they got these observations that they're going to look at. So just wait for this to pan over to there. So yeah, the spacecraft is called the ESA spacecraft, was launched from Russia in 2005. And now we're going to fly to Venus, as the spacecraft did. So here we go. It does take a little while for us to get to Venus. So I chose to look at a tour of Venus because as a kid when I was growing up, when we were learning about the planets in our solar system, we were learning that Venus has a runaway greenhouse effect. And that is due to a large amount of greenhouse gases in its atmosphere, which led to extremely high surface temperatures, and that kind of really interested me as a kid because at the same time we were talking about global warming on Earth and how we were increasing the greenhouse gases in our atmosphere, and that can lead to a greenhouse effect. And it was kind of a comparison to what could possibly happen if that greenhouse gas emissions into our atmosphere are left unchecked, because we'll get this runaway greenhouse effect. And in the future, Earth could have really high surface temperatures like what we see on Venus. And that would make life here pretty much impossible, because nothing would be able to survive at temperatures that high. So they were talking about here how on Venus we see these movements here, and that's not actually the orbit of, or the rotation of Venus. That is actually just the movement of the clouds on there, and those clouds are what are driving that greenhouse effect. And the clouds on Venus are made of sulfuric acid. And yeah, here they're talking about how that's not the planet's rotation, those are cloud movements. So yeah, you'll see this movement here, and the movement of these clouds are around 350 kilometers per hour, which is pretty darn fast. And then the most of Venus's atmosphere is made up of carbon dioxide. And then the amount of pressure that you're experiencing on the surface of Venus is immense. It is about equal to what you would find at a 1 kilometer depth below the ocean on Earth. So that would pretty much just flatten you. Then they got a lot of acid rain on Venus, and as I mentioned earlier, from that runaway greenhouse gas effect, the surface of Venus is very hot. It's around 872 degrees Fahrenheit. So, of course, life wouldn't be able to exist at that temperature. And then it takes 243 Earth days for Venus to make one rotation. But then it takes only 225 days for Venus to orbit around the Sun. So that is significant because they're actually completing one yearly orbit around the Sun before the planet actually makes one daily rotation. So now we are going to be zooming in below the layer of clouds here. Or they're just taking the clouds away. And it looks a lot different here. You start to begin to see their landmass. And they're going to mention it here, but a large majority of Venus's surface is made of volcanic rock and lava. Yeah, at least 85% of Venus's surface. And then there are some smooth parts here in certain parts of Venus. That was created a long time ago by large volcanic lava flows. There's very few smooth parts though. See, they got like right here and right here, where those red arrows are pointing. And then they have a few areas called coronas, which are volcanic domes. And they are going to talk about how they were most likely formed. So right here you have a corona. And they believe that they were made by large plumes of hot material rising up from Venus's mantle. And they created these dome shapes which then collapsed back down, which made these large craters. And that's what the coronas are. And this one here is called the Artemis Chasma. I don't know if I'm saying that right, but that's what it would be. And yeah, that is the Artemis corona. Most astronomers believe that these coronas show up because they contain a lot of iron oxide. So that's probably something important to note there. But this script just goes on to explain how a large majority of Venus's features were formed and what shaped it into becoming the planet that it is today. So yeah, I just found this really interesting because of that runaway greenhouse effect and how that could possibly one day happen on Earth if greenhouse gases are still emitted into the atmosphere at the current level rates that they are today. So I just like looking at Venus because it kind of reminds me of what Earth could possibly look like if we're not careful.